Hey Grade 5. This week we're talking about a different kind of 3D measurement. See, cubes are all well and good when we're talking about solid objects, but it should be pretty obvious if we're looking all around us that not everything can be measured in cubic centimeters. Right now, for example, I'm drinking a cup of coffee. If I wanted to say how much I'm drinking, it would sound pretty weird if I said I'm drinking about 300 cubic centimeters of coffee. You know what? Coffee isn't the best example for this. Let's talk water. Oh, perfect. Okay, so this is still all related to volume because the units we use to measure fluids, liquids, and gases are still closely related to cubic centimeters. You've probably already guessed what kind of unit I'm talking about. It's the liter. Just like meters, I can divide liters up into smaller parts by adding prefixes to them. I have 1,000 millimeters in a meter, so I have 1,000 milliliters in a liter. 100 centimeters makes a meter, 10 decimeters makes a meter, so 100 centiliters, 10 deciliters also make 1 liter. If I have 1,000 meters, I have a kilometer, and if I have 1,000 liters, I have a kiloliter. It's all exactly the same stuff you've already got used to, just with an l sound instead of an m. We call the amount that something can hold its capacity. Capacity. It can be deceptive. This cube and this water bottle definitely look pretty different. They can both hold about 1 liter of water. Now, if you've got a sibling, you've probably been in an argument before over who got the big glass. I know when my younger sister and I were kids, we fought about this every time our mom would give us soda, because we wanted to make sure we got as much as possible. Looking at these two glasses, it certainly looks like this Maple Leafs glass should hold more. The water level in the glass is already higher than the top of this jar. But watch what happens when I pour one into the other. They actually hold the same amount. Now this jar may be shorter, but it's also wider. Because fluids take on the shapes of their containers, measuring capacity in milliliters or liters gives us a chance to see how much we actually have, rather than how much it looks like we have. While one container may look bigger than another, when we actually measure them out, we see we have the same capacity. Little kids are bad at recognizing this though, and my poor mother still had to put up with a lot of fighting over orange soda. So why did I switch my coffee to water earlier? And what does all of this have to do with our friend, the cubic centimeter? Well, the metric system's all tied together by something that everyone in the world should have access to. If you're a living human being, you have to have access to a source of fresh water. If you don't, you're not going to be a living human being for very much longer. This means that all of our units are related to one another by water. This is pretty obvious for temperature in degrees Celsius. We took all the temperatures at which water is a liquid, split them up into 100 equal parts. At 0 degrees, water will turn into a solid. At 100, it'll turn into a gas. And anywhere in the middle, it's a liquid. But water also holds our other measurement systems together as well. We have 1 cubic centimeter here. Now, if I was to fill this 1 cubic centimeter with water, which I won't because it's made of paper, it would hold exactly 1 milliliter of water. Get 1,000 of them together, like in this paper reproduction of one of the thousands blocks we'd have in the classroom, and, well, 1,000 milliliters makes 1 liter. This paper cube and this water bottle actually have the same capacity. They both hold about a liter. This all actually links to weight as well. Now, this 1 cubic centimeter, or 1 milliliter of water, would weigh exactly 1 gram. 1,000 grams would make a kilogram. A liter of water should weigh exactly 1 kilogram. Now you'll get into all the weight considerations and all of that stuff further on in your math career. For right now, it's just kind of a fun thing to know, but I do think it's a pretty fun thing to know. This chart might help out a little bit. Let's take a look here. This is for all of the units that we use in the metric system. The basic unit could be meters, liters, or grams. These different prefixes, kilo, hecto, deca, deci, centi, or milli, do the same thing to every single one of those units. Now, usually we don't worry too much about deca or hecto. They exist, but normal people don't use them that often. That's more for very specific scientists. We do use kilometers, kiloliters, and kilograms, though. In each of those cases, they mean 1,000 of whatever we had. So a kilogram is 1,000 grams, kilometer, 1,000 meters, and today, for capacity, a kiloliter is 1,000 liters. Then we get to the ones that are smaller than our base. We don't talk about deci very much, but we can. There are 10 deciliters in a liter, there are 10 decimeters in a meter, and there are 10 decigrams in a gram. We do use centi quite a bit, especially when we talk about meters. Centimeters there are 100 of in 1 meter. But there are also 100 centiliters in a liter and 100 centigrams in a gram. You just don't hear about them nearly as often. Milli gets used for all of them pretty frequently. You'll hear a lot about millimeters. There are 1,000 of those in a meter. You'll also hear a lot about milligrams. There are 1,000 of those in a gram. It's usually how we measure medicine, because we need to measure out very small amounts of something to keep it safe for us. Finally, today, you're going to be using a lot of milliliters in some of the work you're doing. There are 1,000 milliliters in a liter, and that is, again, to remind you, the amount of water that fits inside 1 cubic centimeter. Kinda cool. Okay, that brings us to the end of today's video. Now remember, the main takeaway for you guys here is that capacity is a lot like volume, but it's used to measure things that don't have a definite shape. This means liquids and gases, or fluids. Liters and meters get divided up in pretty much the exact same way. You already know there are 1,000 millimeters in a meter, so it shouldn't be that big of a stretch for you to remember that there are 1,000 milliliters in a liter. If you multiply the number of liters you have by 1,000, you'll know how many milliliters you have. And if you divide the number of milliliters you found by 1,000, or move the decimal 3 places to the left, you'll find your liters. I hope this has given you a good idea of what capacity is and why we use it, as well as a couple of fun facts about the foundations of the metric system, which is probably not a combination of words you expected to hear today. Stay tuned to this channel for more Math and Science Grade 5. I'll keep making videos for new topics as we get to them throughout the year, and you guys just have a great week. I'll see you later. Bye. Alright, that was for you, Mrs. Ramsey. I couldn't let this video go without at least one star wipe.